Alright, so for this second video, I'm going to do some examples on how to graph a piecewise function. I just had to make it a separate video so I could do it in a different system so I could actually do the graphing. Okay, there's a bunch of different strategies to graph piecewise functions. I'm going to show you a way I like to do it and that I think kids have found helpful in the past, but it's not the only way. There's lots of other videos on how to do it. Okay, but just like the piecewise functions when we were looking at a graph or evaluating from a function, we really need to focus on the restrictions of the domain. So normally, if we were to just graph f of x equals 5, so if we're just going to graph f of x equals 5, y, that's the same thing as the line y equals 5. I'll just go ahead and graph that line, right? I will just graph the line y equals 5. No worries there, no restrictions there. But what I have to be careful about with this is it's only y equals 5 or f of x equals 5 from negative infinity to negative 3, where f of x is less than or equal, or x is less than or equal to negative 3. So what I like to do, I like to kind of draw on my graph where I'm going to have each function. So let's do f of x equals 5 in blue. So I like to go on my graph and think, okay, here is negative 3, right? My function is less than or equal to that. So when I'm graphing f of x equals 5, I'm only putting the graph on that part. The only x values for f of x equals 5 is when x is less than or equal to negative 3. So I like to make a table of values. When I'm graphing, I like to make a table of values, and these are both lines, right? F of x equals 5 and f of x equals negative 2x minus 3. Those are both lines. So 2 points is enough to graph them. You always have to put a boundary point in. The edges of the interval is a boundary point. So for this one, because it's sandwiched with negative infinity, the only boundary point is negative 3. So I'm going to plug in negative 3. Okay? So I'm always going to plug in negative 3, and then I'm going to plug in at least one other number that's in that domain. So just pick a number that's less than negative 3. So we'll do negative 5. Okay? Now when you input any number to f of x equals 5, and that's what this graph is for, or this table's for, when you input any number into f of x equals 5, it's going to give you 5. So we're going to have, right, because there's nowhere to plug it in. That literally means that y is always 5. That's what the function is. So we're going to have a point then at negative 3, 5 and at negative 5, 5. So negative 3, 5. We'll have a point, and negative 5, 5 will have a point. Okay? Now, when I connect them to form a line, I'm going to go towards negative infinity. It starts at negative 3, and notice it's or equal to negative 3. So negative 3 is included. We're not going to put an open circle. We're going to fill that circle in because it's included, and then we're going to go this way forever. So that is the piece for that section of the graph. Okay, so now we'll do the other piece of the function, and we can choose a different color. We'll do this one in red. So this is for when x is greater than negative 3. So it's not always the case. Sometimes there's a gap. Here it's starting, the other function ended, this one's starting. And it's going to go for all x is greater than negative 3, so all the way to positive infinity. Okay? And then we're plugging in for that function. So down here in red, the function we're going to use for our graph is negative 2x minus 3. So we're going to plug in negative 3 again to this function now because we have to plug in the boundary point, and then we'll plug in one other point that falls in that domain. You could plug more than one, but remember, for straight lines, if they're not going to curve, you don't need more than one. So we'll just plug in one. 0 is a really easy one to plug in too, right? The y-intercept's negative 3. And then I'll just plug it in. So negative 3 times negative 2 is 6, minus 3 is 3. 1 times negative 2 is negative 2, minus 3 is negative 5. Okay, so I'll just plot those points. I'll plot my boundary point at negative 3, 3, and remember, this time it's an open circle because it's negative 3 isn't actually in the domain. Everything up until negative 3 is, right? Negative 2.99999 is, but negative 3 is not included. So we'll do an open circle, and then we'll plot the other point, 1, negative 5, and we can kind of check ourselves and see if this makes sense because we know what a line is, right? This has a slope of negative 2, so it makes sense that it's kind of steep and that it goes down forever, okay? Or that it goes downhill. Another option is you could have just plugged in the boundary point. You could have just plugged in negative 3 and said, okay, this is where I'm going to start. Okay, I'm going to show that my function goes all the way to negative 3 because that's what my domain shows. But then you could just go down 1, over 1, down 1, or down 2 over 1, down 2 over 1. You could also know that negative 3 is the y-intercept, so you could have done that. All of that would help you. Oof, this is not a straight line. This is going to be rough. Okay, let's see if I can do this. Gonna connect these dots. Slow and steady. There we go. Okay, I'm like using this like screen thing, and I'm just writing on it. It's crazy. Anyway, this is my graph. I'm done. I haven't answered all the questions being asked here, but I have graphed the piecewise function. Okay, so I like to, at the top of my graph, break it up into sections, break up my XY table into sections, and just plot the points and connect them. Some people like to graph the lines fully and erase them. That works too. Okay, but last but not least, let's answer some of these questions. So this is indeed a function. How do I know it's a function? Well, it passes the vertical line test, right? If we go from left to right and scan it, the only place where it looks like it might overlap is at negative 3, but notice negative 3 is only included in this top function here. It's not included in the bottom one, so it's still, you know, if I put a vertical line there, it would still pass the vertical line test, right? So yes, it is a function. Let's do some evaluating. We kind of have some options here. We can look at the graph or we can plug them in. So for f of negative 4, we can look and we can say, okay, is negative 4 less than or equal to negative 3? Yeah, it is. So we're going to plug it into the top function, and anything we plug into there is going to give us 5. So it's 5. You could also look at your graph. You could go over to negative 4, up, you hit your graph at 5, and it's 5. Okay? For 0, is 0 less than or equal to negative 3? No, it's greater than negative 3. So it's going to be in this bottom function. Negative 2 times 0 is 0, minus 3 is negative 3. Okay? Or, again, we can go to 0 on our x-axis, go down, and we'll see that it hits at negative 3. Last but not least, f of 3. Okay, look, that looks like it's going to be off our graph, so that's not an accurate way to look at it. So let's plug it in, right? But we know it's into the bottom function here because 3 is greater than negative 3. Okay, so then that's going to be, what, negative 9, yeah? And we're done. Okay, so this is a piecewise function with 2 pieces graphing it. On the next slide, we're going to graph one with 3 pieces. Okay. All right, so for this graph, we're just asked to graph it. We have 3 different sections, okay? And they're also all linear. We're pretty much only going to work with you guys graphing linear functions in this class. You can do a piecewise function with anything, right? We saw in that last video, you can have sine, log, squared. We're mainly going to focus on straightforward, just lines, so that we can get more familiar with the process instead of having all these complicated functions as well. Okay, so what I'm going to do here, let's just take a look at it. We've got x minus 1 when x is less than or equal to negative 2. Okay, we've got 2x minus 1 when x is between negative 2 and 4, with 4 being included, negative 2 not being included. And we've got that x is greater than 4 is negative 3x plus 8. Okay, so here's how I'm going to set it up. I'm going to just do different colors for everything, okay? First, guys, going to be teal. Okay, so when x is less than or equal to negative 2. So I kind of like to draw my circle and draw it filled in to show I don't know what the point is yet. I don't know what the y value is going to be yet, but I know it's going to be filled in, and then my function's going to go this way. Okay, you know, it helps if you have like colored pencils or highlighters when you're doing this too, right? It's a good idea. Oops, my color didn't change. There we go. This function I'm going to do in red, okay? So from negative 2 to 4, I've got my middle function, 2x minus 1. But notice at negative 2, it's not included, so I'm going to do an open circle here. And then at 4, it is included. So I don't know exactly where my y values for this segment is going to be, but I know that on one end it's going to have an open circle, and on the other end it's going to have a closed circle. Negative 2 is not included, 4 is. Okay, and then for the last one, right, we've got x is greater than 4, so that's going to be an open circle, not greater than or equal to, just greater than 4. And then it goes this way forever. Okay, so my graph is 3 different chunks. I'm going to be graphing 3 different things here. Okay, I'm going to make a big XY table, and I like to work from left to right, first function to last function. So I'm going to start with the blue function. Remember, we must plug in the boundary points. In this case, there's only one because the other boundary is infinity. So I've got to plug in negative 2. And you know, sometimes I like to show my closed dot here just to really hammer home the idea of, you know, we're filling this dot in. So for negative 2, we find f of negative 2 would be, that would be negative 2 minus 1, which is negative 3. So negative 2, negative 3 is a point. And then remember, I just need to plug one more point in because it's a straight line, right? These are all y equals mx plus b form. I don't need more than another point. So I'll plug in just to get the general shape of it. Why don't we plug in negative 5? Okay, so if I want to find f of negative 5, that's going to be, oops. Okay, casual pen malfunction, but we're back. That's going to be negative 6. Okay, so I've got enough points for the blue line, and then you can just go right in and do it. You don't have to wait until the other ones are found. So negative 2, negative 3 is going to be down here. Negative 5, negative 6 is going to be here, and then it's going towards negative infinity, right? And I have that circle filled in because it is included in my function, in this function. Oof, bad line, terrible line. I can do this. A little better. Why do I want to go up so bad? There we go, kind of. You get the point, right? There's my line. It goes through my 2 points. Okay, and then I'm done. I'm done with the blue function. I can move on to red. Okay, now red has 2 boundary points, right? We have the negative 2 and the 4. So I have to plug both of those in because I have to plug all boundary points in. So I'm going to plug negative 2 and 4 in. And that's really all I have to plug in, right? It's a line, so I only need 2 points. And we're going to remind ourselves that negative 2 is an open circle. 4 is a closed circle. So I plug in negative 2. I'm going to get negative 2 times 2. I switch those. Minus 1. It's going to be negative 5. I plug in 4. 2 times 4 minus 1. That's 8 minus 1. That's 7. Okay, again, because negative 1, the y-intercept is between negative, or the y-intercept 0 is between negative 2 and 4, I could just plot my y-intercept and then like graph it. But I think it's easiest because you don't always know if you're going to get perfect numbers on the boundary points to just plug in the boundary points and connect them, right? So -2 is -5. So we'll put an open circle. It's not my best open circle, but it is open. Got to make sure we know it's open, because if it wasn't, it would not pass the vertical line test because you would have 2 outputs for 1 input. And then 4, 7, that's going to be a closed circle. And then this is a long one. Let's see how we can do here. There we go. And we're done with that segment. Okay, and last but not least, we will do the green segment, right? And even if we wanted to, we couldn't really, like, we couldn't use the y-intercept here and be like, okay, I'm going to graph this, because the 0, x equals 0 is the y-intercept. It's not greater than 4. 0 is not greater than 4. So we're going to plug in the boundary, 4, and we're going to remind ourselves that it's an open circle. And then we're going to plug in another number that's less than 10, so it's on the graph, but greater than 4. So I don't know, 7. 7 seems good. Okay, we plug in 4. What's that function? -3. -3 times 4 plus 8. That's -4. 7. I don't know if this will be on the graph. What the heck? Negative. Okay, that's not going to be on the graph. Scratch that. That's not going to work, is it? We're going to do 5 because 7, that's a point off the graph. Okay, what we could also do is we could also just plot 4, -4, and then use our slope to find another point. So even though we can't use the y-intercept, we could plot, 4, -4, and then just go down 3/1. But let's just plug in 5 for the sake of consistency. -3 times 5, I definitely didn't erase everything. I'm sorry if that bothers you. Plus 8, -15, plus 8 is -7, okay? All right, let's plot these. I went back and erased it because it was bothering me. 4 and -4 is here. Oop, messed up. That's going to be an open circle, right? That's why I remind myself in like 10 places, because it's easy to just want to fill in your point and not pay attention, right? That's going to be an open circle because 4 is not included in the domain of the last function. Then another point is 5, -7, and it looks like if I count my slope, right, down 3/1, another point would be 6, -10. Can connect my points. And bam, the graph is done. Okay, so there's 2 examples of graphing piecewise functions. This one we saw here is probably about as complicated as it's going to get in Algebra 2. But the truth is, this strategy, like, it works for all shapes, lines, functions, right? If this was like a cubic, an absolute value function, and a quadratic, we could still use this strategy of just plugging in points in each section. Okay? So I hope this helped. It sucks that we lost that class time, but all the other Algebra 2 classes, like the other 4 sections in the school, didn't lose any class time. So we got a little behind. So thank you for taking the time to watch these videos, even though they're extra and outside of class. We'll talk a little bit about this stuff on Monday, but then we kind of got to move on to Unit 2. All right?